Hey, good morning, kids. What we're doing today is we're going to be doing a geologic case study, which is your virtual work from home lab for Unit 2. You guys are going to be tracking the movement speed of a tectonic plate. What we're going to do for today is we're going to work through how to do the Hawaiian Islands together, and this will be your practice round. I'll be happy to give you guys as much help as you want. Later on, you'll be working on the Galapagos Island chain, or if you really want to get ambitious, you can pick a different one. I provided some data on that. And you'll be tracking down some data sources, citing them, and then writing up what's going on with that, as well as determining the speed of that tectonic plate. So here's your prompt. What we're looking at is first we need to go get a topo map. That's a map that shows kind of the height of different things. So let's go search for that. Hawaii topo map. And let's bring up some images. Oh, this one's beautiful. Of course, that's only got the big island. We kind of want the whole island chain. Here, this one's not bad. So what it's showing us is the relative height and depth of stuff. And if we cited our source, we could pop this right in our document. Speaking of which, you guys should make two items here, two files. First is a Google Doc where you're going to cut and paste all your stuff into. Please use the file name lastname.geology case study. Also, you're going to need sheets so you can do your math and data crunch. And again, please use the lastname.geology case study file name. All lowercase, period separating them, no space. That way it makes it easy for me to track who's turning in what and all that good stuff. All right, so question one was go get a topo map. You guys will notice that these are basically mountains from the oceanic plate all the way up to the surface level of the water and possibly beyond. In addition, it looks like right here, see there's some mountain chains that don't actually break above the surface of the water. And hopefully we'll be talking about that a little bit later too. But yeah, we're basically looking at mountain chains in the middle of an ocean. And next question coming up here is what tectonic plate is it located on? You guys can track that down. What type, if any, of boundary is creating those features? Is it on a boundary, first of all? P.S. It's not. This is a hotspot island chain. It's not a volcanic island arc based on convergent oceanic plates or something like that. So you guys are going to need to read about hotspots and how this works. The first two links I put below will definitely get you all the info you need for that. So just read about them there and describe how this mechanism works. What's going on with that? What is a hotspot? Okay, next up, and the place where we're going to focus today is on number 4, which is how fast is the tectonic plate moving? We're going to put together some data on this and then try to graph it, and hopefully the slope of that graph, if we set it up correctly, is the answer to the question we're looking for. One possible final step will be some dimensional analysis to convert it to appropriate units. Then you guys are going to discuss the long-term outcome of weathering and erosion on whatever's happening, and then cite your sources. So with that, let's jump in. I've included some links already for the Hawaii case study. So I'm going to click on this link right here and bring that up, which is, where did it go? Here it is, Hawaii volcano ages. So I found a list of the age of the different islands, or more specifically the volcano on each island, which is even better. I'm just right now going to cut and paste that whole thing. Control C, copy, and paste. Okay, now a couple things. Excel or Microsoft, not Microsoft, Google Sheets, it doesn't want to deal with a range of numbers. It just wants a number. It doesn't want that dash in the middle. So we've got some choices to make, first of all. Do we want to go when the volcano ended, which is the most recent date? Or do we want to go when the volcano started, which is this older date back here? Or do we want to go with the average of those? I could see pros and cons for a bunch of those different choices. I'm going to just arbitrarily choose the start date. But you could easily make either of those other choices justifiable too. So whatever you want to do with that. Okay, so now we've got ages of the volcanoes in millions of years, along with their associated name right here. I don't think I need this column. I'm going to delete it. We care about the volcano more than we care about the island, although if you can't find a specific volcano on the island, let's say you're doing the Galapagos later, you could just go with the island name instead in general. So you could go by island if you have to, but if you can go by volcano on the island, that's even more specific and better info. All right, next thing I need to do is I need to go track down distances. We know that velocity is distance over time. So here's my time data. I'm gonna need to put some distance data right here. In the long run, I think that I want this in centimeters per year. So I'm gonna work in the metric system. I'm gonna work with distance in kilometers. And I'm gonna work from a starting, I'm out in the garage, my computer broke. Gonna work with a starting point here. Let's go with this one and work our way backward. So Mauna Loa, okay, so I'm gonna go right here over to Google Maps and bring up Mauna Loa. There it is. Cool, I've actually been there, it's pretty cool. Okay, then we're gonna go track down the next volcano and pop that in on the other one. And it is right over here. And now here's the cool part. I'm gonna right click on this spot. I'm gonna go distance to here. Boom. And it tells me the distance between those two locations. Right down here, it says 68.9 kilometers. So now I'm gonna call this my point of origin, my reference point. And from there, I measured 68.9 kilometers to the second volcano. Now I'm gonna go ahead and grab the third volcano. And go back to Google Maps. And try that again. Gonna keep using Mauna Loa as my reference point. And I'm gonna go right click and say distance to here. And now I've got a total, oh, actually this is fancier than I want, I think. I might just go directly between these 2 points. But we'll leave it. It's looking pretty cool, zigzagging a bit. Okay, 152 kilometers. 152. Now I'm gonna go to West Maui. I might use the search term volcano. Just to make sure I've got it. And I'm gonna right click on this spot and go distance to here. And now I'm up to 201.5 kilometers. Okay, we're gonna keep going. Maps, there we go. What? Oh, dang. Okay. We're gonna kill this. Go away. Nope. Okay. We're gonna zoom back out. Go grab this one. And then right click distance to here. Measure distance between these 2 spots. Okay. So now I'm getting 161.6 kilometers. All right. And we'll basically keep going with this. 9. Oh, yeah. Okay, cool. Nope, that's not working. Okay. Boink. Boink. Measure distance. From here to here. Okay. 212.9. Alright. You guys will keep going with this. By the way, post-erosional, I don't think you will get data on that one. I've done this once before. So you can toss one of these if you can't get data. We just need enough data points where you can map it out. Let's go all the way to this one though, just to get a kind of an endpoint for all this. And what is that? That's not even an island, right? Go zoom in on this. This should be telling you something interesting regarding that last question. See that island? What? You can't see that island? You mean there's no land sticking out above the water? Interesting. Okay. Good to know, right? Let's kind of get this final distance here. All right, we got 1,055 kilometers. All right, anyway, when you got a bunch of data, do the whole thing, of course. When you got a bunch of data, we're gonna highlight it. We're gonna go insert, chart. We're gonna make sure we got a scatter plot. Over on the Customize menu, we're going to take some time to add axes titles and make sure we got stuff labeled, distance in kilometers, age millions of years. But more importantly, we're going to go down to Series, turn on the trend line, and make sure that it is giving us an equation. Okay, and now let's read out what this equation is telling us. This is the slope right here, and it is telling us that, oh, you know what we might want to do actually? Weird thought. Sorry, just got distracted. Let's go edit this under the Series menu. Never mind, I guess there's not an option here. Don't worry about it, it's all good. Okay, so this is on the y-axis, this is kilometers. On the x-axis, this is millions of years. And so it's saying that it moves 90.2 kilometers every million years. Here's the thing, I don't really want kilometers per millions of years. What I'd like you guys to do is use dimensional analysis like we practiced on Wednesday, and please convert your answer to centimeters per year. So this right here is 90.2 kilometers per million years. Please convert to centimeters per year for your final answer. And we have successfully answered the hard part of this, which is question 4. Right here. How fast is the tectonic plate moving relative to the hotspot? We're assuming the hotspot is stationary. More or less true, I think. Okay, please show your work with dimensional analysis, just like we practiced on Wednesday. Show that the units are cross-canceling as you go. And that should do it. You guys should do the Hawaiian Islands today as practice. Hit me up in office hours, which I'll post to Classroom if you have any questions. Then on Monday, you guys are going to be doing part 2 of this, which is the Galapagos Islands, or I actually found data on other hotspot island chains. You can see a bunch of them are on the same tectonic plate and move at the same speed, but you can also see that there are some other ones out there that move at different speeds. I kind of think the Canary Islands would be fun to do right here, if anybody's interested in that. You can try a different one too, but if you just want the default choice, then please choose the Galapagos Islands right about here. It'd be the same process. You might need to go off island age instead of volcano age if you can't get specific enough data off the web. Please cite where you get your data too, so I can follow up with that if I need to. And I recommend using an app like EasyBib, which goes right in your browser. Basically just click on it, it automatically makes an APA or MLA citation. If you guys don't mind setting it to APA, that's preferred in science. And yeah, should be an easy lab. Hit me up with if you guys have any questions. I hope you're having a good day. Bye. See you in office hours.